Today we have Paolo, who is the coordinator of the Scavenge project. Paolo Dini is a senior researcher at Communication Network Division of CTTC in Barcelona. From 2001 to 2005, he worked as a research assistant in computer science and system information communication departments at the University of Rome, La Sapienza. In 2005, he worked with the Research Center on Software Technologies and Research Assistants, and the same year, he was also assistant professor at the Infocom department. He has been lecturing the course of Comunicazione Elettrica there. 2008 and 2011, he received 2 grants from the Cisco Research Center in San Jose, California. Yeehaw. For his research on, yeah, when you land in San Jose, you hear this. Yeehaw! Welcome to San Jose.
It's a bit on the north of California, so it's close to San Francisco.
Exactly, yeah. Even with the trumpet. Anyway. Paolo has an active participation in research projects, I would say a few of them, and is currently the coordinator of the Scavenge European Training Network. He has published many papers in scientific journal, magazines, and international conferences. His research interests encompass wireless networks modeling and optimization, with particular emphasis on energy saving and energy efficiency, energy sustainable network architecture, protocol and algorithms, smart grids, self-organizing network, cognitive networking and machine learning, radio resource and mobility management. Okay. In the talk, you will talk about architecture for future mobile networks, which are referred to as 5th generation mobile networks. In particular, you will look at the interaction with the electricity grid, integration of the radio asset network with the distributed renewable energy system, and also by showing the main building blocks and meters to achieve self-sustainability of the whole system. Okay?
Thank you, Miguel.
Thank you so much.
Thank you for your presentation and your introduction. So I would like to spend some words on this concept of energy sustainability for future mobile networks, and we will see also some interaction with other players in this game. So actually, when I was preparing the presentation, I started with a list of slides that I already have. So I collected all these slides, and I see that I wanted to make a lot of things. I want to speak about many things. So I put it down a list of keywords that I was mentioning during my presentation, and I see that all these keywords are referring to different area of knowledge. In particular, a big set is referring to mobile networking, which is the main core of my talk today. But also there is a big set of keywords that are referring to control theory, including optimization research and optimal control, and artificial intelligence like machine and reinforcement learning. And finally, there are also a set of keywords that are referring to power grid and essentially to the smart grids. So the idea of this presentation is to be at the intersection of these 3 fields, three domains. So I would try to explain the best I can this interplay with these three things. So for this reason, I structured the presentation in 3 parts. So the first one is about the concept of energy sustainability and giving you some motivation on top of this concept, why we introduce mainly in this project, in this European Training Network. Then the second part is a parallelism between the energy grids and the mobile networks, including energy sustainability. And the third part is about how to control this architecture that I will introduce in the previous 2 parts. So let's start with the first part. Probably you may know these pictures because they are typically referred to many speakers, and they are about the increase of traffic demands for next generation system, ICT system, and in particular the fact that the mobile networks are the drivers for this increasing traffic demands. So I do not enter into the detail of all the things because I think that you already know all the detail of these things. But the most important thing on this is that probably in the future we need further deployment of new networks. So, and this has let's say, an implication mainly in two domains. The first one is about the environment, because if we are deploying new network and these networks are operating a lot, they are consuming energy, so they have an impact on the environment in the sense that they are, from one hand, they are consuming resources like energy, and they are polluting environment. So these are some figures that I reported on some reports that we have for, where is the point? This is for the ICT industry in 2013, and these are some forecasts for 2030 if we are following this traffic, this increase in traffic demand. So for sure we have to do something sustainable in order to maintain the carbon footprint of our industry, ICT industry, in a given margin. So the second impact is on the economy. So first of all, the mobile operators are experiencing a decreasing in their revenue because of many reasons. One of these is the fact that there is already a fully penetrated market, mainly in the Western countries. And the second fact is that they are paying a lot of money for the energy bill. So I put here some reference about what these guys in Western Europe are experiencing in 2007, so some years, 10 years ago. That the bill that they pay for the energy is equal to the cost of the personnel for operating and maintaining the network, which is a lot. And also there is a current trend of increasing the energy. So probably now, if we are repeating these exercises, probably the energy bill is higher than the personnel cost. So again, this is a sustainable problem for the future communication network. Because sustainability is not only about environment, it's about the environment, how the environment is used by human beings, and how human beings are organized among themselves through, for example, economy. So all these things are regarding the sustainability of the network. And since mobile networks are the main drivers of the traffic demand increase, we are focusing on mobile network in our project. And in particular, we are referring to the radio access network, since it is the most energy consuming part of the whole mobile network itself. So actually 80% is the energy consumed by the radio access networks. Okay, so this is actually not a completely new topic in the research. We, more or less a decade ago, we have been starting working on this problem. And if you look at the literature, there is this research area called green communication and green networking that are focusing on solving this problem. Actually, what was the main goal of this research was to have a more energy efficient system. So we had the past school of the scavenger training program was about this part. So we had some talks about energy efficiency, some techniques that can help to increase the efficiency, like massive MIMO. So here I list actually the main things that you can do, I mean, high level perspective, to increase the energy efficiency of the network. So the first is to have a more efficient hardware design, mainly for power amplifier and radio frequency part. The second is about architecture. So we had a nice talk last school about the separation between control and data plane. And the other one is about, let's say, technology. So massive MIMO could be a technology to decrease the energy consumption of macro base station. And then the other one is a set of methods or procedures that help us to, let's say, decrease the energy consumption of the system. But all these things are related to energy efficiency. What means? So we want to decrease the energy consumption of the system or of a given device. And actually, what these techniques are doing is that they are trying to achieve that the energy consumption of the system is proportional to the traffic load. So the idea is that most of the time, since the network is overdimensioned, most of the time the base station, for example, in our case, since we are studying RAN, radio access networks, are in idle mode, so there is very few users to serve, and then we are wasting energy there. And for example, we can switch off the base station into a given time in order to decrease the energy. This is one of the main examples to do this. And this is also valid for devices, because if you are imagining a sensor networks, most of the time the sensors are not sensing any variable of the environment. So they can be put in a sleep mode to save energy. So this is the idea of this research area. But what I want to include in my presentation is a concept that is going beyond the energy efficiency, and we usually refer to this as energy sustainability, that is including energy efficiency in the domain. In fact, this is a definition that I used to have for sustainability, defined by UNESCO, and it is defined as the process of using resources in a way that does not compromise the environment or deplete the materials for future generations. So the idea is to use resources in a, let's say, good way, and it's not only about efficiency, something that is, you can imagine, is already bigger than the simple efficiency of a system. And also they are referring to the fact that this is an interdisciplinary approach, so it's not only a matter of environmental engineer, us as telecommunication engineer, electrical engineer, computer science engineers, also have to include these paradigms in our studies and in our design. And now I would like to elaborate more on this. So the efficiency again is to minimize the energy consumption of a device or a set of devices. What we want here is to, following this strategy by the European Union, is to use less resources. So in case of energy, we want to use less fossil resources. So we want to decarbonize the system, the energy system, and we want to use more renewable energy or other low-carbon technology to supply our network devices. This is something that is changing the design of the system. So we want to use different paradigms for the design, so long-lasting, maintenance, repair, reuse, remanufacturing, refurbishing, and recycling. So this is kind of change also the economy, because now we are used to have another paradigm that is more linear. So we take the resources, we make the product, and then we dispose of the product. In this new paradigm, we have something circular, because okay, we can use some resources, we manufacture, we use, we operate the system, but then we try to recycle, and then to enter in a loop and to waste less and to use less and less resources. So this is the idea of using renewable resources. Okay? And if you want more details on this, you can refer to this manifesto for a resource-efficient Europe that has been released in 2012, and there are all the details of this roadmap. So in our case, the main idea is to supply in our system the base station with renewable power. In our case, I plot this solar panel, which is the most used, let's say, energy harvester in the world. And in this work that we did some years ago with Marco here and some colleagues at Politecnico di Bari in Italy, we made a feasibility study of this architecture. You know that you can have several layers, the macro layer, the micro layer, and the small cell layer, or picocell layers. And we see that if we are using this solar panel plus a battery for a smaller base station, we have very deep operative expenditure savings in the life cycle of the base station. which is not exactly the case for the macro layer because of the energy consumption of the macro layer and also the cost incurred when you have to install the additional hardware, because probably you have to rent also a LAN across the base station. And also without any kind of optimization, we can reduce 20% of the carbon footprint of the network just to install this plugin, let's say, this add-on. So the idea is that without anything, just putting this new harvester there, we are achieving 20% less carbon footprint at the expenses of a capital expenditure to buy the new hardware, but you have the return on the investment very soon. So there is no problem for the operator to install this kind of new hardware in the system. Okay, so this is the idea. But installing this new hardware, we are increasing the variability of the system, because the network design normally has been done in the past without considering energy. So you are defining protocols, methods, architecture without having any problem on the fact that you have a limited amount of energy, as in the case of solar panel installed in the base station or even in some devices. So we have to face with this limitation and with the fact that you have an energy arrival process which is not completely forecasted, or you can have some stochastical model of this, so you have to take into account this, plus the fact that you have an heterogeneous traffic demand, as is normally done in the network design. So another thing that we have to take into account in this energy sustainable architecture is at which extent we can be autonomous from the power grid. So it makes sense to have a network that is completely self-sustainable and is off the grid, or we can make some play with the grid to exchange energy, to buy, to sell energy with the energy grid. And an important role in this game is played by the energy storage, so the battery. So if I can store some energy, maybe I can be self-sustainable. If I can't, I mean, probably I cannot, and I have to drain some energy from the grid. So it's important also to include this part in the story of the energy sustainable architecture. So actually, what I'm saying here, that we have to face a new approach to network design. But of course, these are new challenges, but we have the current one. So when you are designing a network, now, for example, the 5G network, you know that you have to deal with heterogeneous devices. So we have human type communication like mobile phones, but we can have also machine type communication like sensors or even machine. So we have to deal with different types of traffic and different types of devices. So sometimes you are referring to device-to-device communication. So the idea is that there is a direct communication between two or more devices instead of passing through the whole network infrastructure. And also in this field, for example, in sensor network, there is a huge study on battery management in order to enlarge the life cycle of the sensor network and not to replace the battery every month or every year. And also another interesting field in this part is called cyber foraging, which is actually the idea to offload part of the computational power from a device, which is probably low power device, to an high power device which is located in the network. So in this case, we can prolong the battery of those devices. So the other trend more in the network part are related to the network densification. We had courses on this. So we know that now in the future the trend is to densify more and more the network. So we will have probably one micro layer and several layers that are more for capacity enhancement on a given zone, like plotted in this area here. For example, this is a business center, so I need much more capacity there. So the operator may want to deploy more base stations, smaller base stations, in order to have frequency reuse and then to increase the capacity in that zone. And we can even have more radio access technology. So now we have LTE, LTE Advanced, that are defined as 4G, 4G plus generation. In the future, there is this study on, they call new radio for 5G. There will be millimeter wave for sure. There will be Wi-Fi, which is a never-ending story. So we will have multiple radio technology that have to coexist in the same zone, and maybe in a very how to say, not in the same frequency band, but very correlated frequency band. And also another trend that we are seeing for, let's say, for simplifying the network management and operation is to softwareize the network. We had a course, of course, on this in the previous schools. And what is the main idea of this concept? Is that the operator don't want anymore to have dedicated hardware with dedicated software on top to run the network, but they want to exploit general purpose hardware and then to put on top a virtual machine that are acting as, for example, a base station, or are implementing a given function of that device that they want to deploy. So this trend is called also, let's say, cloud computing as general, or software-defined network and network function virtualization. So the general idea is that you can move function across the network depending on a given setup that you might have due to the traffic demand and to the mobility of the user, to the energy consumption. I may want to dedicate just one hardware to make all the function, then switch off the other so I can consume less energy. So this is something that is advocated by this concept. So as you can imagine, all this plus the previous challenge related more on the energy sustainability part require some intelligent control of the system. This is the reason why we need let's say, an intelligent control of the system, which should be automated and self-organized. So in this sense, I refer to the talk by Lorenza before, because she is already introducing this concept for a given set of functions that has been already studied in the framework of 4G standardization, without considering energy sustainability. So with this, I conclude the first part. I forgot to say that if you have any question, comment, remark, just raise your hand and I will interrupt and try to interact with you. So I really like when there is an interaction, so we can go more in the detail of the part that you have more curiosity. So don't be shy and stop me whenever you want. So in the second part, we are going to have a parallelism between the energy grid and the energy sustainable mobile network. Yeah, there is a question.
So you talked about moving the network functions around according to the traffic demand.
Yeah.
So I mean, the network function, so it's an application basically, a software which is moving around some network nodes. How do you implement that? I mean, it's identification. So right now the network nodes have a particular, they have a particular identification in the network. So you know where to go to access that. But when a function is moving around.
Yeah, I mean, there is a very huge literature on this. And actually they are studying a control architecture to manage this. So you will have different layers and APIs, interfaces, that are controlling the location of the function and which function has to be implemented and run in a given set of devices.
So, it will be
So there are already protocols that are more or less standardized. Maybe you know something that is called OpenFlow, Open Daylight. These are kind of standardization ongoing on this field to control exactly where to put and how to implement and deploy the function in a more flexible way. Okay.